All right, so we've got two buddies working on this problem, and they came up with the idea that, maybe it would just be easier to just find the solutions for the original inequality that we have up here by getting it to be one equation. Now, what did he do to get this equation? And hopefully you were able to decide that he took that 2x squared plus 5x minus 3. We said, okay, let's make that equal to x squared plus 4x plus 3. And then he just got everything on one side. So subtracted x squared from both sides, subtracted 4x from both sides, and subtracted 3 from both sides. And we get that function. Now he just calls that f of x, or y, equals x squared plus x minus 6. Now, use Desmos if you'd like to graph that function, and let's take a look at what we have. All right, when we do that, what we end up with is this graph. Now, the solutions to this parabola, y equals x squared plus x minus 6, are the x values are basically our x-intercepts. So negative 3 and 2. So what we know is that our x values that satisfy that equation are 2 and negative 3. So what that tells us is, if we think about our number line, like we did in the previous problem, where we have our number line, and, let's say we go negative 3, negative 2, negative 1, 0, 1, 2, 3, and so on. The 2 and negative 3 that we identified by looking at the parabola represent the boundary points for our number line. So we know, and again, going back to the original inequality, it's a less than symbol, not a less than or equal to. So we know we're going to have open circles on negative 3 and 2. And then we, remember, broke our graph, our number line, up into 3 regions, and then picked values from each region to plug into the original inequality. So the original inequality, I'm just going to write here, is 2x squared plus 5x minus 3 is less than x squared plus 4x plus 3. And we're going to plug in our values from each region. So let's pick a value from each region. I'll start here in region 1 and pick the value x equals negative 4. And I'll plug that in to my, let me do this here. So where x equals negative 4, plug it into my original inequality, and you get something that looks like this. And we just have to decide if that is a true statement or not. So go ahead and evaluate that, and then check your answer here in just a second. So what we get is 9 is less than 3. And I think we can all agree that that is not true. Okay, so let's pick a point in between negative 3 and 0. So in region 2, I'm going to pick the point x equals 0. So if I plug in 0 now, I'm going to get 2 times 0 squared plus 5 times 0 minus 3, and then 0 squared plus 4 times 0 plus 3. This one's a little bit easier. We're just trying to see if this is true. So we get negative 3 is less than positive 3. That is true. So I know that this region works. And then I would try my final region somewhere in region 3, and I'm going to go ahead and pick x equals 3, plug it in, and you will get, I'll write it all out here, and then you can pause the video and evaluate it and see if it ends up being a true statement or not. So check to see if this is true. Come back and check your answer. And you end up with 30 is less than 24. I think we can all agree that that is not true. So region 1 and region 3 do not work. So the only thing that does work is everything in between in between negative 3 and positive 2. So anything in this area here is part of our solution. Again, recognizing that we needed open circles on the boundary points.